From the moment we first gazed upon Saturn's rings through rudimentary telescopes, it captivated our imagination. But it wasn't until 1997 that we sent an emissary to truly unravel its secrets. That emissary was Cassini, a joint venture between NASA, ESA, and the Italian Space Agency, a testament to what we can achieve when we pool our collective genius. For almost 13 years, Cassini orbited Saturn, its rings a celestial halo against the backdrop of a truly alien world. It showed us the majesty of Saturn's rings in unprecedented detail, unveiled the mysteries of its moons, Titan and Enceladus, and beamed back data that revolutionized our understanding of gas giants. Cassini wasn't just a mission, it was a love letter to exploration, a testament to human curiosity, but even love stories have their final chapter. And for Cassini, that chapter was a fiery plunge into Saturn's atmosphere. Why? Why would we intentionally destroy such a remarkable feat of engineering, a spacecraft that had given us so much? That, my friends, is a question we'll unravel in due time. Titan, Saturn's largest moon, has always been shrouded in mystery. Its atmosphere, a thick haze of nitrogen and methane, obscures its surface from view. But Cassini carried a secret weapon radar. Like a cosmic echolocator, Cassini's radar pierced through Titan's veil, revealing a landscape eerily familiar yet startlingly alien. There beneath the hazy skies lay not oceans of water but vast, shimmering expanses of liquid methane. Imagine a world where methane falls as rain, carves canyons and collects in lakes and seas larger than any on Earth. That's Titan. Cassini showed us a world engaged in a bizarre mimicry of our own, with a hydrological cycle not of water, but of methane. It's a world so cold that water ice is as hard as rock, forming mountains and plains. And on those frigid plains, Cassini detected something even more intriguing: organic molecules, the building blocks of life. Now don't get too excited. It's far too cold for life as we know it on Titan. But the presence of these organic molecules, combined with the moon's active geology and potential for subsurface water, makes Titan a tantalizing target in the search for extraterrestrial life. Maybe not little green men, but perhaps something more along the lines of microscopic methanogens thriving in that alien sea. The images Cassini sent back from Titan were breathtaking. We saw river channels snaking across the surface, evidence of methane flowing like water on Earth. We saw vast dune fields sculpted by Titan's winds, and we saw what appeared to be cryovolcanoes, spewing forth plumes of water ice and ammonia, like geysers on a cosmic scale. Titan is a world of cold beauty, a world that challenges our very notion of what life could be and what worlds could harbor it. And it was Cassini that opened our eyes to its wonders. Thanks to Cassini, we no longer see Titan as just a blurry dot in the sky, but as a world as diverse and complex as our own, a world ripe for further exploration. In fact, NASA has already greenlit a mission called Dragonfly, a drone-like spacecraft designed to hop across Titan's surface, exploring its methane lakes and searching for signs of life. It's a testament to Cassini's legacy, a mission inspired by the discoveries of its predecessor. But Titan wasn't the only Saturnian moon to capture our imagination. Cassini had another target in its sights, a moon that would prove to be even more surprising than Titan and Enceladus. Enceladus, at first glance, seems like an unlikely place to look for life. It's a tiny moon, barely 300 miles across, a mere speck compared to behemoths like Titan. And its surface, at least initially, seemed rather bland, a world of ice, reflecting sunlight back into space. But Cassini, ever the diligent explorer, noticed something peculiar. As it flew past Enceladus, its instruments detected something unexpected: a faint but unmistakable plume of water vapor erupting from the moon's south polar region. Now, any sign of water in space, especially liquid water, gets us astrophysicists pretty excited. Water, as we all know, is essential for life as we know it. So, the discovery of these plumes on Enceladus was a major event. It meant that beneath that icy shell, Enceladus harbored a secret: a global ocean of liquid water, kept warm by the gravitational pull of Saturn and its other moons. But Cassini didn't just detect water vapor, it found something even more intriguing: organic molecules, the building blocks of life embedded within those plumes. And not just simple organic molecules, but complex ones, the kind that are precursors to the proteins and amino acids that form the basis of life as we know it. Suddenly, Enceladus went from being a small, icy moon to a prime candidate in the search for extraterrestrial life. Think about it. A hidden ocean, warmed by tidal forces, rich in organic molecules, and possibly even hydrothermal vents, similar to those found on Earth that teem with life. It's like something out of science fiction, yet it's right there in our own solar system, waiting to be explored. Cassini's discovery of Enceladus's plumes and its subsurface ocean has revolutionized our understanding of icy moons. It's shown us that even in the coldest reaches of our solar system, where sunlight barely reaches, life may find a way. And it spurred a flurry of activity within the scientific community, with plans being drawn up for future missions to Enceladus, missions that will search for definitive signs of life in that alien ocean. Imagine landing a probe on Enceladus, drilling through the ice and sending a submersible down into that dark alien sea. It would be like exploring a completely different planet right here in our own backyard. And who knows what we might find. It's a tantalizing thought, and one that wouldn't be possible without the discoveries made by Cassini. Of course, we can't talk about Saturn without talking about its most iconic feature, those magnificent rings. Even through a simple telescope, Saturn's rings are a breathtaking sight. But Cassini showed us those rings in a way we'd never seen before, revealing their intricate structure and dazzling beauty in unprecedented detail. Cassini's images revealed that Saturn's rings aren't just a single, solid band, but rather a complex system of countless individual particles, ranging in size from tiny grains of dust to chunks of ice the size of houses. These particles are constantly colliding and interacting, creating waves and ripples that spread through the rings like cosmic sound waves. One of the most surprising discoveries Cassini made was the presence of spokes in Saturn's rings. These dark, ephemeral features seem to form and dissipate over time, their origin still a bit of a mystery. Some scientists believe they may be caused by electrostatic forces, while others think they may be the result of interactions with Saturn's magnetic field. Cassini also observed moonlets embedded within the rings, tiny moons that shepherd the ring particles, keeping them confined in their orbits. These moonlets act like cosmic sheepdogs, their gravity sculpting the rings into the intricate patterns we see. And let's not forget the sheer beauty of Saturn's rings. Cassini's images revealed a dazzling array of colors and textures, from the brilliant white of the A ring to the faint dusky hues of the C ring. The rings are a constantly evolving work of art, a celestial ballet of light, shadow and motion. But Cassini's observations of Saturn's rings weren't just about aesthetics, they also provided valuable scientific insights. By studying the composition and structure of the rings, scientists were able to learn more about the formation of our solar system and the processes that shape planetary systems around other stars. Cassini's legacy includes a treasure trove of data on Saturn's rings, data that will keep scientists busy for decades to come. And who knows what secrets those rings still hold, waiting to be unlocked by future missions. Saturn may look serene from afar, but beneath its cloudy veil lies a turbulent world of storms and swirling winds. Cassini's instruments pierce through Saturn's atmosphere, giving us a glimpse into the heart of this gas giant. One of the most striking features Cassini observed was the giant hexagonal storm raging at Saturn's North Pole. Imagine a hurricane 6 times the size of Earth, with winds whipping around at over 300 miles per hour, and you'll have some idea of the scale of this storm. Scientists are still trying to understand the dynamics of this bizarre hexagonal vortex, but it's clear that Saturn's atmosphere is a place of extreme weather. And then there are Saturn's auroras, shimmering curtains of light that dance around the planet's poles. Like auroras on Earth, Saturn's auroras are caused by charged particles from the sun, interacting with the planet's magnetic field. But Saturn's auroras are far more powerful than Earth's, and they can last for days, rather than just hours. Cassini also made detailed observations of Saturn's magnetic field, which turned out to be surprisingly different from Earth's. Earth's magnetic field is tilted at an angle to its axis of rotation, but Saturn's magnetic field is almost perfectly aligned with its axis. This has puzzled scientists for years, and it's still not fully understood. By studying Saturn's atmosphere, storms, auroras, and magnetic field, Cassini has given us a deeper understanding of how gas giants work and how they interact with their surroundings. And it's provided valuable insights into the processes that shape our solar system and planetary systems beyond. Cassini's mission to Saturn may have ended in 2017, but its legacy lives on. The data it collected continues to fuel scientific discoveries, and the images it sent back will forever inspire awe and wonder. Cassini revolutionized our understanding of Saturn, its rings, and its moons, revealing a system more diverse and dynamic than we ever imagined. Cassini's discoveries have paved the way for future missions, like Dragonfly to Titan, and potential Enceladus landers or orbiters. These missions will build on Cassini's legacy, pushing the boundaries of our knowledge even further. Cassini's story is a testament to the power of human curiosity, the importance of international cooperation, and the daring spirit of scientific exploration. It's a story that reminds us that there's still so much out there to discover, and that the universe is full of surprises. Now I'm curious, would you like to see an infographic summarizing Cassini's 20-year journey and its incredible discoveries? Let me know in the comments below.